Solving puzzles with Python, and the puzzle we're going to solve today is what two numbers when multiplied together give you 428. What we are going to do is go through our 428 times table twice and pull out every single combination of numbers that when multiplied together give you 428. So we will start with 1 times 1, that won't give you 428. We will then proceed to 1 times 2, that also won't give you 428. Eventually we will get to 1 times 428, that will give you 428, and we will end up with 428 times 428. That won't give you 428, that will far exceed it, of course, but that is the extent of our code. That's when our program will finish. So without more ado, let's get on with this. Today I'm going to use an online compiler, onlinegdp.com, which is one of the very good online compilers out there. There are several to choose from. The advantage of using an online compiler is that you don't have to have Python or any language installed on your machine. It runs in the browser, on the server, on the website. Multiple languages you can write programs with. We're using Python 3. And let's see how easily and quickly we can solve this puzzle. Let's declare our number as a variable. So number is 428. And we are going to use a for loop initially to go through 1 to 428. So for I is traditionally the inbuilt variable counter for a for loop, and we're going to go from 1 to number to our number 1 to 428. It's for loop, you need a colon at the end. For lols, let's print it out and just check that it's going to work. So print, and I'm going to use the string of I. Don't have to convert it to a string when you're just printing out I, but I'm going to because I'll need it later on. So print string of I. If I run that, it should give me 428. There we go. 400. So our program does every number. We will want a second set of numbers to multiply with our first one. So to do that, we'll simply repeat the loop, have a nested loop. Okay. And that will go through the numbers from 1 to 428 again. To show you this, let's develop our output statement. So we also want it to print out the J counter, so string of I. Plus, let's put the multiplication sign in there. We will need it sooner or later, and then we will put in a string of J. And let's see what sort of output we get with that. Run. Missed out a joiner there. Indentation error there. And there we have it. We have our 428 times table twice. The computer's still calculating it, as you can see, but what it does is it gets number 1 from the first for loop, and then takes 1 428 times using the second for loop. Then it picks 2 and then takes 2 428 times. Okay, we'll stop it. We now want an if statement that will detect the right answer. So if I times j is equal to our number, which is 428, then we want it to print out the formula, the multiplication formula. We will also would like it to print out the actual formula as well. So let's put the equal sign, let's finish it off. So if I times j equals, and let's use the string of I times j. Looks like it's properly created. Okay, so only if I times j equals our number do we use the print statement. That should speed up the whole thing and reduce the number of outputs. Let's run that. And that was a lot quicker, and it produced 4 outputs. We got in 4 instances we've detected that there are multiplying 2 numbers together gives you 428. Is it right? Actually, a quick visual check will tell us that no, it's not right, because 1 times 428 gives us 428, and we should encounter that twice. Why is that happening? Or in this case, why is that not happening? It is because the for loop goes from 1 to 428, and it jumps out on the top line. So as soon as it hits 428, it ceases to run. So it doesn't actually carry out the calculation involving 1 times 428. What we need to do is put a +1 there, which takes it to 429, which means it will do 428, and it jumps out at 429. Okay, let's run that again. And there we have it, 1 times 428, 428 times 1, and the numbers in between. So we have solved our puzzle using Python, and we have solved with just 1, 2, 3, 4, 5 lines of code. This program could be developed, of course. We could get rid of duplicates. We could also modify it only slightly to detect prime numbers. If your output is only going to be 1 times 428 or 420 times 1, if it was only that, that would mean that 428 was a prime number. Let's try and 429, is that a prime number? No, that's not a prime number. Let's do a prime number that we know. Let's do 29. 29 and run. There we go. 29 is a prime number, so you get just the 1 times 29. You don't get other factors of 29. And there we have it. 6 lines of code, 5 lines, 1, 2, 3, 4, 5 lines of code to solve today's puzzle. Thank you for watching Solving Puzzles with Python.